Dear students of class 10th, today we will be starting a new chapter, that is periodic classification of elements. Here in this first lecture we will be discussing the various earlier attempts that were made to classify the elements. So starting with the classification of elements. First we will see what is classification. The arrangement of elements into different groups on the basis of similarities in their properties, whether that would be physical or chemical properties, is known as classification of elements. The classification of similar elements into groups makes the study of elements easier. There are about 118 different elements that are known so far. There were the earlier attempts of classification. In the earlier attempts to classify elements was grouping them into two groups known as metals and non-metals. At that time only 30 elements were discovered so far. The defect in this classification was that it had no place for metalloids, that are the elements which have the properties of both metals as well as non-metals, which were discovered later. So there need to be new attempts to be made to classify the elements. So the first known classification was Daubernier's classification. The first classification is known as Daubernier's triads. In 1817, J.W. Daubernier, a German chemist, tried to arrange the elements with the similar properties into groups. So he classified the elements in the increasing order of their atomic masses into groups of 3 elements, and that group was known as triads. So the name Daubernier's triads. In each triad, the atomic mass of the middle element was approximately equal to the average atomic mass of the other 2 elements. So in this way he classified the elements in different triads. But the defect in this classification was that all the then known elements could not be correctly classified, as only 3 triads were classified from the known elements at that time. For example, one of the triad was lithium, sodium and potassium. When they were arranged in the increasing order of their atomic masses, that is lithium 6.9, sodium 23 and potassium 39, the average atomic mass of the first and third element was 22.95, and it was approximately equal to the atomic mass of sodium, that is 23. So in this way Daubernierre classified the elements on the basis of their atomic masses into 3 triads, and this classification was known as Daubernier's triad, but it had many limitations. Newland's law of octaves. It was John Newland who arranged the elements that were known at that time into the groups in order of the increasing atomic mass. He stated that he started with the elements having the lowest atomic mass, that is hydrogen, and ended with thorium, which had highest atomic mass, and it was the 56th element. He found that every 8th element had properties that were similar to that of the first element. He compared this to the octaves found in the music, and as such he called it the law of octaves, and it was known as Newland's law of octaves. One of the Newland's octave was from lithium to sodium, and it was found that the properties of lithium and sodium were same, as the sodium was the 8th element after lithium, and there were other octaves as such. Limitations of Newland's law. The law was applicable to elements up to calcium only. It contained only 56 elements, and it was assumed that only 56 elements existed in nature. No more elements would be discovered in the future. And third, in order to fit the elements into the table, Newland adjusted 2 elements in the same slot and also put some unlike elements under the same node. For example, cobalt and nickel are in the same slot, and these are placed in the same column as fluorine, chlorine and bromine, which have very different properties than that of these elements. Iron, which resembles cobalt and nickel in property, had been placed differently away from these elements.